Hello, I welcome you all to this another interesting screencast. The problem reads, determine the magnitude of the resultant force acting on the screw eye and its direction measured clockwise from the x-axis. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have two force vectors acting on the screw eye. Let me call this as F1 and then this one F2. So F1 is equal to 6 kilonewtons and F2 is equal to 2 kilonewtons. Alright, so how do we find the resultant and the direction of these two force vectors? We are going to employ two methods. One method is the parallelogram method, where we are going to employ the cosine and the sine laws. Okay. The other method is the addition of the x and y components, okay, to get the resultant as well as the direction. Okay. So we are going to show both methods. It's really up to you to choose which method is okay for you. Great. And that's the reason why I have two figures. In the first figure, I'll employ the parallelogram. In the second figure, I'll employ the addition of components of these vector forces. So let's start with the parallelogram. So we know that the resultant for these two force vectors is going to be closer to the bigger vector, right? Force vector, right? So let's assume this is our F resultant, right? This is what we want to find. What else? We also want to find the direction measured clockwise from the x-axis. This. Okay? So these are the two quantities that we want to find. We want to find the resultant. We want to find the direction. Great. So first things first, let's draw the parallelogram. So I'll start from the head of this vector. I'll have one vector like this, which is parallel to F2, like so. This is good enough, right? Great. What happened to this? This is our F2. Alright. Then I'll have another vector. So let me call this F2. I'll have another vector parallel to F1. Something like that. Okay. Something like that. Great. Okay. Then we'll have the resultant from this point, from the tails of these two vectors to the heads of these two new vectors that we've drawn. Of course, this is F2. Alright. So we have drawn a parallelogram and our resultant force. And we need this angle here. Alright. maybe let me use another color. I'll use blue. We need this angle here. Let me call it theta. But there is also this inner angle here that we're going to call alpha. Okay. All right. So let's start doing the work. So what we need to do is to pick one triangle. Look at these triangles. We have this left triangle, okay, and we have this left triangle. So the right triangle, left triangle. So we are going to go with, you can pick either of these, they are the same. I'll pick the right triangle. Alright. So now we need to find the internal angles. Let's transfer the angles inside these internal angles. Why meaning these internal angles? I'm really interested so much with this angle here because it will help me find FR using the cosine rule, right? Great. So let me draw a coordinate system that goes through this point. That goes through this point. Something like this. Great. So let's look at these angles that we have right now. This is too long. Great. So we have 45. Look at this one. 45, right? Do you agree to say this 45 is the same as this one here? Is that fine? Of course, it is the same. Great. Because it's the same vector with respect to the horizontal axis. What about this one here? Do you agree to say this angle here, which is F2, sorry, this is F1, right? How did I put it as? Okay, this is F1. So do you agree to say this angle here, okay, this angle here is also equal to this, right? Because it's the same vector F1, and we have this particular angle which is clockwise with respect to the x-axis, right? So it's the same angle which we can replace there as 60 degrees. Is that fine? Great. So with this information, then we can employ the cosine rule. We can employ the cosine law. Okay. So FR is just going to be equal to square root. Remember the cosine rule? Square root of F1 squared plus F2 squared minus 2 times F1 times F2 cos this angle here, okay, which is 45 plus 60. Great. There we go. Okay, so we know what F1 is. We said F1 is 6, F2 is 2. So we know what F1 is. It is 6 kilonewtons, and F2 is equal to 2 kilonewtons. Okay, and therefore our resultant is just going to be equal to, grab your calculator and plug in those numbers. So 6 squared plus 2 squared minus 2 by 6 by 2 cos 45 plus 16, okay, which is just 105. Square root of that. Of course, you expect a positive and negative. We are interested in the positive value. This is a 6.80 kilonewtons. Theta is going to be equal to alpha plus 45 degrees. right? For us to find alpha, we are going to use the sine law. Okay, so say sine alpha divided by f1 is equal to sine 45 plus 60 divided by FR. Therefore, alpha is going to be equal to sine inverse of F1 sine 45 plus 60 divided by FR. So we know all these values, so we just replace F1 and FR. So let's plug in. So we have a F1 is 6 sine 45 plus 60 in brackets divided by 6.8. Sine inverse of that, we get a 58.46 degrees. Therefore, theta is just going to be equal to, we plug this in, we plug this here. Alright, once we do so, this gives us a 103.46. Alright, so we are done with the first part. Let's go to the second part. So all this was under the parallelogram method, right? All this was under the parallelogram method. Let me just move this down like so that I just write the title on top. So all this was under method 1. This was under method 1, which we called the parallelogram method. Alright, so let's employ the other method. Thread underlining. Alright, so let's use the other method, which is the addition of components. So the other one is addition of components. Okay, so method 2 is using the x and y components, right? Great. So what we need to do here, this is our coordinate system. Our coordinate system is as follows: x positive and y positive, like that. So let's draw the components. We'll start with F1. Of course, this is our F1. This is our F2. Okay, so F1, we have a component in that direction like so. Okay, we'll have another component like so. Alright, and then let me use green for that. Doesn't matter which color you use. So F1, I'm going to have a component like so. I will have a component like so, and then I'll have another component like so. This is my F1. F2, I'll have a component like so, and another component like so. Okay, so let's label this. So this one is going to be equal to F2 cos 45, which is just equal to, you know what it is, we can leave it like that. This is F2 sine 45. This one is F1 sine 60, and this one is F1 cos 60. Okay, so there we go. We need to now sum up these components and then calculate them, sum them up, and then get the resultant. So let's draw the table. So the table is going to have the force F. It will have X components, then it will have Y components. So let's label that. So I have F1, I have F2, then I have the summation of F. So the X component there, F1, I have F1 is 6, so this is 6. Mind the direction is negative 6 cos 60 degrees, and the Y component is also negative 6 sine 60. Then F2 is positive 2 cos 45. Then the other one is negative 2 sine 45. Okay. Then the summation, of course, we're adding up this like so, and then we add up also there like so. So let's sum them up. So we have minus 6 cos 60 plus 2 cos 45 gives us a minus 1.5858. The final answer will have 2 decimal places. The reason I'm using 4 is just to maintain the accuracy. The other one is 6 sine 60 and 2. This is a 2, right? It looks like this is 2 sine 45, right? It's 2 sine 45. So this gives us a 6.6104. All right. So what do we have? We have Frx equal to minus 1.5858 kilonewtons. We have Fry equal to 6 point, it's also a negative, this one, right? Negative 6.6104. Okay, so if we are to draw this, it looks like this. We have X in this direction, okay, and then we have a Y like so. So this is how it looks, right? And we also need to find the angle. Okay, mind you, the angle that we are going to find here, it is this one here. I'll call it, let me call it beta. Okay, but we need another angle because the question is to find the angle measured with reference to the x-axis. So we need this angle here. We need this angle. Okay, we need this angle. All right. That is the angle I'm going to call. We need this angle. Okay, I'm going to call this as my theta. Okay, I'm going to call this as my theta. All right, so there we go. So we need to find now the resultant force. So our resultant force using Pythagoras, our resultant force is just going to be equal to Fr is just equal to square root of frx squared plus fry squared, and fr is just equal to 1.5858 squared plus 6.6104 squared. Okay, so this is just equal to 6.80 kilonewtons. So let's find first beta, then we'll find what theta is by subtracting from 180. So beta is just equal to tan inverse of fry divided by frx. Okay, then beta is equal to both are negative, so the negatives will cancel out. So 66104 divided by 1.5858, tan inverse of that, it just gives us a 76.51 degrees. Theta therefore is just going to be equal to 180 degrees minus beta. So theta is equal to 103.49 degrees. A minor difference due to rounding offs and so on. So let's outline the solutions. We have FR from this first method is equal to 6.8, and theta is equal to 103.46. In the other method, FR is equal to 6.8, and theta is equal to 103.49. Alright, I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, see you in my next screencast.